Welcome to today's webinar, Accelerating Network Operations with Big Cloud Fabric's GUI. This is the second part of our GUI webinar series. The theme today is intent-driven zero-day deployment. My name is Angelique Medina. I'm the Senior Product Marketing Manager here at Big Switch, and I'll be your host for today's webinar. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video on demand, and if you have a question regarding today's topic, simply go to bigswitch.com/webinars and submit a question using the link provided. We also have a number of handouts for today, so you can access them again on the right-hand side in the Handout tab. Joining me today is Cedric Hobbs. He's the GUI architect here at Big Switch Networks. Welcome, Cedric.
Thank you.
So we have a fairly full agenda for today, so we're going to go ahead and get through it pretty quickly. So picking up basically where we left off from the last session, we're just going to do a quick recap. Then we're going to get into intent-based zero-day provisioning, what effectively we mean by that. And then the bulk of the session is going to be a live demonstration with Cedric leading that. We'll also have time at the very end for some questions as they come up during the broadcast. So for those of you who missed part one of this webinar series, we encourage you to go to our website and navigate to the resources section where you can view an archived recording. In our first session, we discussed traditional versus next generation networking paradigms, and we also introduced Big Cloud Fabric, our data center switching platform. And then we went through an orientation of our graphical UI. For today's session, we do assume that those listening in have some familiarity with what Big Cloud Fabric is and does. But just as a quick review, Big Cloud Fabric is a leaf-spine cloth fabric that operates as a single logical switch managed by high availability SDN controllers. It's a software-based solution that deploys on open networking hardware like white and bright box switches. We refer to Big Cloud Fabric as a next generation solution. So to clarify what we mean by that, we're going to just do a quick recap on how it differentiates from traditional networking. So in legacy networking, each switch is an autonomous unit that requires individual configuration and management. These architectures can be pretty complex, where each switch within the network has to be consistently configured to prevent any one of them from creating routing errors. Provisioning, upgrading, troubleshooting, all of those operations can be manual and time-consuming. Gartner refers to this as the status quo, or basically humans as middleware, performing repetitive, often quite manual operations. Automation is absolutely available for legacy networking. So for example, some vendors talk about zero-touch provisioning, when what they really refer to is basically a workaround to the problem of handling a large number of autonomous switches. For instance, in a day zero scenario, you might have scripting workflows or configuration templates that can be applied or pushed out to the switches, and that improves efficiency and reduces the time it takes to deploy, but ultimately this is just a workaround to the problem of having to deal with configuring and managing traditional switching infrastructure. In contrast to this model, intent-based networking is software-driven and effectively offers a new way to build and operate networks. And this improves availability and agility compared to traditional legacy approaches. Intent-based networking focuses on the what versus the how. So the key aspect, or the sort of key aspect of intent-based system involves obscuring a lot of the complexity of implementation and assurance. And this allows users to simply specify a high-level intention rather than the configuration details. With an SDN-based model, such as we have with Big Switch Networks, the control and management planes are abstracted and centralized, so it's much more straightforward to enable an intent-based approach to networking. And this is what we're going to talk about next. So again, the focus of today's session is day zero intent-based provisioning, and we're going to cover this in the demo. But first, we're going to quickly cover more specifically what we mean by intent-based networking. So intent-based networking it's not simply a rebranding of network automation or orchestration. Gartner's differentiated intent-based networking from both of these, as well as from traditional means of management. So with network automation, this is absolutely a component of intent-based system, but they're not one and the same. So again, as we mentioned earlier, the ability to define high-level operations without also having to specify detailed configurations is a key part of intent-based networking and distinguishes it from network automation, where at some point with network automation, you will still have to explicitly define configurations. The other really important capabilities of an intent-based system are validation and awareness, which in terms of awareness, we often refer to this as visibility. So Gartner breaks down a complete intent-based networking system into 4 categories. The first of these is translation and validation. So with translation and validation, the system takes a higher level business policy, or the what, if you will, as an input from end users and converts it to the necessary network configuration, or the how. The system then generates and validates the resulting design and configuration to ensure that it's correct. With automated implementation, this is where the system can configure the appropriate network changes across existing network infrastructure. And then the third of these is awareness of network state. So this is where the system ingests real-time network status from the systems under its administrative control, and then it provides some means of delivering or displaying that information to the user. And finally, we have assurance and dynamic optimization or remediation. And this is where the system is continuously validating in real time whether the original business intent is being met, and then corrective actions can be taken in those cases. So Big Cloud Fabric provides all of these capabilities. In the case of translation of intent, we can break this out into 2 ways. The first is the ability to receive simplified inputs through some kind of intuitive UI. And this means basically, it could be providing one-click options for standard operations like adding a switch or fabric trace, or it might mean interacting with a business system that would then provide higher level instructions. So in that instance, it's really key to have a robust API. So there are a number of operations that we can point to as examples of intent-based networking with Big Cloud Fabric. In particular, some of our troubleshooting capabilities are really pretty cool, and we're going to cover those in an upcoming session. But today, we're going to focus on provisioning. Some of the operations that Cedric is going to go through include adding switches and fabric validation. So with that, I'm going to allow us to actually take a look at the UI. So I'm going to hand it over to Cedric, and he's going to walk us through the GUI. Welcome, Cedric.
Thank you, Angeline. It's a pleasure to be here again. Last time I know we talked about, we did an intro to the BCF GUI. We talked about the dashboard and some of the cool charts and heat maps that were really cool to look at. We talked a lot about table functionality, which is a little bit dry, but it's an important part of the GUI. A lot of stuff is done that way, and we demonstrated configuring tenants and segments in the logical space. And we also looked at a table of switches, and then we drilled down to a switch detail page where we started to see some of the more visually impactful parts of the GUI, right? So that switch was drawn in exact detail based on the hardware model and platform. And so today we're going to explore a little bit more of the sort of kind of single pane of glass, more graphical, more visual way of managing your fabric. So I'm just going to, from the login page, sign in again. And I'm starting with the switches page that we looked at last time. And I've got a simulation going in Mininet. So I've got 9 switches sort of kind of started up in my simulator. And 3 of them are meant to be spine switches. And I can tell that just from the simulator putting a 1 in this position in the MAC address. And then the leaf switches are have the 2 in the MAC address. So that's just a byproduct of the simulation. In a real world situation, you should know which switches are which, but the point is here that none of them are connected to the fabric. So they're connected to the controller knows about them, but they're not part of the fabric because there's no role associated with them, right? So we do prescribe a leaf spine topology and it's up to the user to actually kind of configure that for each of the switches. So it's actually something you can do here from the table. In fact, anything you can do in the graphical pages, you can usually do from the table, and I could click a menu item and click configure and start going through that process. But today I want to show a more interesting, cooler way of doing that. So we're going to go to the Fabric page. And this is sort of a single pane of glass of our whole sort of device fabric, right, including the control plane and the data plane. We have a row of controller nodes at the top, a row of spine switches, a row of leaf switches, and then a row of all unassigned switches. So I'm going to start. Well, let's take a look at this. So at the top we have some controls like refresh. I can kind of refresh my data. I can set an auto refresh interval if I like, which I'm going to leave off for this demo. We have day-night mode. So if you prefer it dark, we can do it that way. There's this other button for showing the device's front and backs, which I will kind of get to later because that won't do anything in this setup. And the rest of the layout is split into what I call the sidebar and the workspace. So the sidebar has controls and sort of auxiliary information as you click around, and then the workspace has sort of graphical representations of everything that you're interested in. So this is my sort of development setup, and before I actually do the configuration, I want to explore this page a little bit more using a real live setup. So I'm going to go to another QA controller we have. And by the way, what I just did, pointing you to another controller, is just a development feature. That's not something in production. But now I'm pointing to a QA instance in our lab. And so these are actual switches running, right? So these are already configured. We've got 2 spine switches already configured, and we have 6 leaf switches already configured. And each pair of each leaf switch is part of a pair, which is analogous to a rack in the data center, your top of rack switches. And so you can see there's the name of the leaf group, rack 1 at the top for these leaf switches. And there's also representations of virtual switches on that rack. So let's click through a little bit. We can click each of these nodes. And again, you'll notice that we have a realistic representation of all the devices. So in the case of the controller nodes, we've got a Dell R430 server. And once I click that, you'll see on the left there is some information about the node, IP addresses, interfaces, and some environment data. So this is actually pretty useful, and some optics. In most deployments, you'll have also a standby node, so you can look at both. You'll also see in the graphic that there is a green light, one green light for each of the controller nodes to indicate whether the node is connected or not to the cluster. So let's go down to the next row, which is the switches, the spine switches. And if I click one of those, I'll see a different set of information on the left-hand side. And again, we have 3 lights in the graphic itself. The first 2 lights you want to see green. So the first one indicates that it's connected to the controller. The second one indicates that it's connected to the fabric. And we saw earlier that if it's not assigned a role, it won't be connected to the fabric. But that means it's ready to go, and it's part of the forwarding fabric. The third light is a diagnostic light. So this is really more about visibility. Angelique mentioned that we do have visibility into errors and warnings and validations. And so what the GUI does here is it goes through all those errors and warnings and looks for any that pertain to that particular switch, and then kind of summarizes them here. So if this light is blue, everything's okay. If it's yellow, there's some warnings. And if it's red, there's some errors. And so once I click this switch, on the left-hand side, we see this diagnostic pane, which corresponds to that yellow LED, that yellow light on the switch. So we see there's 2 warnings, an ONI mismatch and a power supply unit's not running. If we look at the upper left, I'm going to take a little detour here. If we look at the upper left, here is sort of a summary of all the errors and warnings in your fabric. So every page will actually show this. And if we drill down to that page, we'll see a list of all the errors and warnings in the BCF system. So it can be quite verbose. So in the case of the fabric, like I said, we just kind of cull all the errors and warnings that pertain to each particular switch. And also from here, I can click a switch title name and drill down to the detail page, which we looked at a little bit before in the last session to see sort of a larger 3D representation of that switch. In this case, we have the Acton AS6700, and again, we see the diagnostic messages here. We see the environment data here where it shows the power supply is unplugged or failed. And in fact, if we flip around and look at the back of the switch, we can see that only one of the PSUs, PSU1, has the green light. The other one is not running, so it doesn't have a light. So if we go back to the Fabric page, these graphical drawings are actually the same drawings that we just saw on that switch detail page. They're just in a flat 2D mode. But we can still see the back. So earlier I talked about this button for toggling the device's front and back views. Now I can click it and see that the backs of each device are displayed, right? So now I can see at a glance where my fans and CPUs are and what the statuses are. Now, this starts out a little bit small. At scale, you might want it small. At a smaller scale like this, you might want it a little bit bigger. So each of these rows has a slider, so we can make it a little bit bigger and see see a little bit more detail, a little bit more resolution on those. I'm going to slide that back. Optionally, we can turn the labels on or off. I mean, when you're configuring, you might want to see that. When you're in more of a steady state, you might not want to see the labels at all and just kind of show what you might see in a data center. And going down here, let's see, we've got leaf switches. This one has one error, so there's a red light here, 1 error, 5 warnings, which is reflected here in the diagnostic table. So this is actually very important. You know, when you're provisioning your switches in the data center, you usually kind of hook everything up, write down some MAC addresses, go back to your desk and decide which one should be, you know, paired up. And sometimes there's some error involved there. So having any errors or warnings here about missing or invalid links can help kind of get the right configuration. Let's see. So at the top of the sidebar, there's some other options for rebooting all connected switches, which I'm not going to demonstrate. I don't want to blow up someone's setup. So if there's any switches that are rebootable, you can do it en masse from here. And there's also a Show Links button. So if I click that, I'm going to see links between all my switches. So what's important to notice here is that Leaf 2A has already been selected, which means I'm only highlighting the links to and from Leaf 2A. All the other links are actually hidden, well, they're in, you know, sort of dimmed so that the links from and to Leaf 2A are shown. But if I unselect it, all of the links are highlighted. You'll also notice that they're kind of hidden. Well, that's because we're showing the backs of the switches. So the links would actually be on the other side of the page, right? So if we switch this view to the front again, now we'll see that the links are sort of in front in the positive Z index, right? So now we see that there's a full set of links across all the switches, and you can see that they're actually hooked up to the interfaces on the switches. And as I drag the sizing, the links will adjust, and you'll see that there's a little square at the end of each link, the size of the interface, and it's color-coded by utilization. So for example, over here we have a link, a port that's in yellow. Let's do that again. In yellow, so that means the utilization is a little bit higher. So you want to see more green here, of course. And again, I can click a switch to sort of limit the links. If I really just want to see the links from or to one switch, I can select that switch to sort of isolate it. So that's really kind of great visibility into your Fabric. We can look at some virtual switches. We know about those. In this case, there's no diagnostic messages, no warnings, no errors about this virtual switch. So you see that there's a blue light for the diagnostic light. All right, so now I'm going to go back to my development setup. Which which is not configured at all, and I want to show how we actually get to the state that we just had, right? So again, because this is a simulation, these aren't real switches, so the graphics for them are a little bit more basic. It's just a generic switch, so there's no model number associated with them, but we can still do the same operations. So I mentioned before, I know from the MAC address which switches I want to be spine switches. So there's the three at the top are the ones that I want to be the spine switches, and there's actually three ways I can do that, right? So one is I can go to the menu next to the switch icon and click the configure pane. And you notice that the fabric role is initially none. I'm going to start typing in a name. I want to call it spine01, and you'll notice also that because I typed in the word spine in the name, it automatically selected the role for me just by looking at the name, which is a nice convenience. All I need is the name and the role, submit, and once it refreshes, that switch is up in the spine row. Right. So you'll notice now that the light for the fabric connection is now green, and if I click, we'll see that the fabric status is up. That's a good thing. That's what we want to see. There are still some errors and warnings, but this is more to do with the fact that this is a simulation, so we can ignore those particular errors. But we have seen that the fabric connection status light has gone green. So that was one way of configuring the spine switch. The second way is just to add it directly from the spine switches row. I'm going to create a spine switch. And in this case, I can just select a MAC address from among the pool of unassigned switches. So I'm going to select number 2 and give it a name. In this case, we don't actually select this fabric role because it's already implied by the fact that we launched this from the spine row. And voila, spine 2 is now part of our fabric. And its fabric connection light is also green. So the third, more interesting way of doing this configuration is just to drag that unassigned switch to the spine row. Now you notice as I drag an unassigned switch, there are 2 rows that will accept it, as you can see by the white highlighting around them. And so I can drop it in either bucket. And as I hover over a particular bucket, there's a little message here saying drop here to configure switch as a leaf switch in this case. In this case, I want to configure it as a spine switch. So I drop it there. And now, again, I just need a name. The role is already implied. Hit enter. And my spine switches are now configured. So that's pretty fun and pretty straightforward. We can do the same thing with the leaf switches. And again, the leaf switches are a little bit different, so they need to be in pairs. So we'll start with one. We're just going to do dragging from here on out. So I'm going to drag the first one into the leaf row and give it a name. And I'm also going to give it a leaf group name. So this is going to be my rack 1, my first switch in rack 1. And now leaf 2, I also want to be a leaf switch, and I also want it to be in that same rack. So I can drag it here. If I just drag it into the leaf row, it'll just launch the configuration to configure it as a leaf switch. So I would need the name, and I would need to give it a leaf group. And I can do that. I can actually select rack 1, and it'll automatically join. I'm going to cancel this because I could also just drag it directly into the rack, into that leaf group, and then I don't have to type it in. The rack 1 leaf group is already set in the dialog, and I just have to give it a name. And once that's done, these are paired. And you'll see now that the leaf group has been configured fully, some virtual switches have started to show up, right? And so if I click this, we'll see that there's a bunch of errors. It's not connected and to either the controller or the fabric. So those 2 lights are going to stay red because this is a simulation. But the third light, the diagnostic, this is showing that there's a missing link. So once we configure a leaf group, it usually takes a few seconds for that to go away. So I'm going to refresh again, and I'll see that that's gone away. So now that there's just a warning, which again is associated with the simulation. So we can do the same thing. I'm going to shorten these. We can do the same thing with my remaining 4 leaf switches. So we want leaf 3 and leaf 4 to be in the same rack. So I'm going to call that rack 2. But I'm going to make a mistake. I'm going to drag leaf 5 to rack 2 instead. And what we'll notice, and we'll give it a few seconds for things to stabilize, in this case, there's a lot of errors associated with leaf 5 now, right? It's showing missing links to the spine switches, missing links to the expected virtual switches. So this is, again, visibility that you've done something wrong, that you've done some incorrect configuration, right? Leaf 5 isn't actually wired to leaf 3 in the data center, in the virtual data center, right? So we can just undo that, clear the switch configuration. It'll go back into the unassigned bucket. And I'm going to move the correct switch, leaf 4, to that rack. And then after a few seconds, the leaf switches will stabilize. But you can see those missing links are starting to disappear. There we go. So now we're all set. So now I'm going to do my last leaf switches again, leaf 05, and we're going to put this in rack 3, and we're going to drag leaf 6 to the same rack. So we're all set. So you can see in a moderately sized deployment, we can have all our fabric configuration done in a matter of minutes. And in this case, there's some links to show. It's less interesting because it's a simulation, but there you have it. Do we have any?
We do. We have a question that came in about seeing a summary of all errors fabric-wide. So if you're unsure of where an error might be occurring, which particular switch it's assigned to, is there a way to see kind of fabric-wide errors?
Well, we do have this kind of global page summary of all the errors and warnings. If the question is, do we have a way to kind of filter that by particular switch, I think the way to do that would be from the fabric page, right? So I mean, the idea is that you're going to go to this page and look for a sea of green, and if you see red or yellow anywhere, you can just drill down to where the problem is. So in this case, you see a red light under the diagnostics, and then you can drill down. So this is where the switch related errors and warnings would be segregated, and you can drill down from here and go about trying to fix the problem.
Mm-hmm. So we're looking at the fabric, the physical fabric. Is there a way to show the logical switches? And
yep. Sure, there is. Well, the tenants and the segments. And I think in the next session we'll talk a little bit about this, but there is a logical topology. So I can sort of kind of configure just a tenant. And we'll configure an external tenant just for completeness. And we call it external, but we know that it's external by the routes. So if there's a default route that makes it the external tenant. And so now when we go to the logical sort of graph, we'll see a drawing of the, I guess that needs to, the external needs to be configured. Anyway, we have sort of a topology here of, all the tenants, well, tenants can be configured to have links to the system tenant. I don't think I configured the external one correctly, but if it were correctly configured, it would also be off to the side. That's the tenant where traffic goes to the outside world. But we have these links here for to show how the tenants are connected to the system. So that will actually show connectivity between endpoints within different segments and different tenants. So we'll talk a little bit about more about that in the next session. I think that will be interesting.
Sure. And in terms of troubleshooting, maybe if you could just give us a little preview of what we're going to be covering in an upcoming session.
So, I think we'll focus on the test path feature. And there's nothing going on here, but basically, from the test path feature, we can go to this page. We can pick endpoints in our segments and simulate traffic between them and show some results here. I don't have a setup for that, but it's pretty cool where we can show the test path will show what hops packets will go through to get from one endpoint to another. So we can do a sort of simulation and then an actual test run as long as the packets are kind of in the network. So that'll be really cool to show.
Great. Okay. So it looks like we're ready to wrap up here. So again, if there are any other questions that come up, you can go ahead and shoot us an email, or you can go to our website. There's additional resources that you can download there. So another way to interact with the Big Cloud Fabric solution is to go to our labs. So we have basically a way to kind of test drive the solution. It's at labs.bigswitch.com, and you can sign up for a free account and you can work through different modules there. It's pretty cool.
I just wanted to say, if you go to the labs, Big Switch Labs, you're going to see an older version of that Fabric page. So what I previewed today is actually cutting edge. We've been responding to user feedback and making it look even a little bit more realistic, giving more diagnostic information. So you'll be able to see that in a future release coming up soon. But the lab still has an older version of that Fabric page.
And so just as a preview for our next GUI-related webinar, it's coming up on July 26th. That's session 3. And we also have an additional webinar that will be sending notices out that's coming up in a couple of weeks. And so you should be hearing about that very soon. But if you would like to check out some of our archived webinars, you can go to bigswitch.com/webinars and check them out there. Thanks again for joining us today. Again, you can go to our website for additional information. That's bigswitchnetworks.com, and we look forward to having you on the next session. Thanks everyone for joining.